All right, welcome everybody. We're going to be talking about three things today. We're going to be talking about Ncurses a little bit. Then we're going to switch over to talk about how to visualize doubly linked lists using bridges. And then we will talk about using the map. So these are kind of three different topics that kind of need to be addressed. Ncurses, bridges, map, yeah. All this kind of stuff. The project itself is designed to be divided into three people. That's why I recommend groups of three. If you don't have a group, please get in one. All right, let's get going. So Ncurses is, let me first justify it to you. So like, if you do this, string s, cn into s, is there any way for you to just have it respond immediately, like when you hit I, like in a video game, right? Like you want to go to the inventory, you just hit I. Is there any way for CN to do that, to have it just immediately respond? I tried getting that to work for years, honestly. I was looking at different like ways of like grabbing the inner buffer of CN and stuff like that, and everything was just very hacky and like it's not really designed for that. So yeah, I made a function called quick read, right? And so the so you do that, and if character equals sorry. So the reason why CN doesn't work the way that we want it to sometimes we just want, as they type keys on the keyboard, for the data to appear immediately in our program. We want that sometimes, like especially in video games. Like you know, when you're playing World of Warcraft, you don't have the game pause. Like the entire system pauses while you sit there and type in an input. You know, it's quite a weird concept, right? And so in video games and things like that, we use what's called immediate mode or raw mode. And so wrong one. Let's see, G++ quick CC. And so it's in an infinite loop right now. Infinite loop, infinite loop, infinite loop. When I hit Q, it immediately responds and quits. Okay. So this is what Ncurses does in essence. Ncurses is the much bigger, much more professional version of my read library. My read library has the ability to do raw mode stuff. By default, though, like I said, when you have string s and cn into s, this is in something called cooked mode. And what that means is, type today, when you run it, you can actually type things in, and look, I can erase them back out and then type them back in again and erase them back out. I can't hit a numpad. I can't use arrow keys at all. But I could hit like Control U. Control U erases the entire thing. Okay. And what's nice about that is that it makes it easy to do strings. Like if you're, sorry, I keep opening the wrong file by habit. If you're inputting a string, it's very convenient to be able to read an entire word at a time like that. But usually in a video game, you just want immediate input. You're going to use either Ncurses or something similar to it, like my read library. Okay. So let's go into the directory over here, RPG41, and let's take a look at how Ncurses works. So Ncurses is a C library, and so a lot of the stuff they do is straight out of C-World. The hardest thing that's going to maybe trip you guys up is how they print things in C-World. So we're used to doing cout, right? That is not a thing that exists in the C programming language. Instead, they use something called printf. And so this is how you print something in C. Okay, there is a print function called printf, and you pass it a string, and it will print that string to the screen. And if you want to have something like a number in there, you can actually do this, where you embed these like weird format specifiers in the middle of the string. They look really strange to students. And then when you do this, it's going to substitute the first parameter here after the string, x into here, and then the next parameter, y, into here. And it substitutes into the string itself. And so this is how things are printed in C. And so if you're going to be doing Ncurses coding, and there's a function called mvprintw, and that uses the format specifiers. It is basically just like printf, the print function, except it has a very important ability. mvprintw allows you to move the cursor on the screen. And so this is going to move the cursor. The MV in there stands for move. It's going to move to that row. So if we have like a 10 by 10 map, this is going to go to row 11, which is going to be one below the map. And column 0, so it goes to row, then column, and then it's going to print x is equal to this, y is equal to this at that location on the screen. And so this is kind of the core function of Ncurses, the ability to move the cursor on the screen and draw things at different parts on the screen. And so if you want to have an inventory system, you could move the cursor over to the right side of the screen and do all of your, inventory stuff over there. You can have your combat down to the bottom part of the screen. You can set it up however you want. Call refresh. That refreshes the screen. To get Ncurses going is kind of annoying. And so I have actually made a function for you called turn on Ncurses. And you can see instead of constructors, they have an init function. Init functions are very common in the C world. We use constructors to happen automatically, but in C world, they use init functions all the time. It's quite normal. And then there's all these other things that turn color on and don't echo the character you type to the screen and clear the screen and stuff like that. So if you ever want to drop out of Ncurses mode, and we want to do this if we ever want to use cin or cout or something like that. If you ever want to use cin or cout, you have to get out of Ncurses mode. And the reason for that is because it's moving the cursor all over the screen. So if you see out like hello world, who knows where the cursor is? It's probably not at the bottom of the screen. And so just like the word hello world will just appear somewhere on the screen. A lot of times it gets all zigzaggy and stuff like that. It looks garbage. Okay. So if you ever want to use cin and cout, turn off Ncurses, just call this function, then do your cin or your cout, and then turn Ncurses back on. And that is my recommendation to you. And so, what did I actually change? All right. Okay. So the code here, you can see I'm just going to hit up arrow, right arrow. So this is functioning code. If you make the functioning code that I give you here work properly, in other words, so that you can't walk through a wall, you can't walk through water, that kind of stuff, then you get a letter grade. And so even if that's all you do on your homework assignment, that'll take you from a 0% to a 50%, because every bullet point you do is a letter grade. So you go from a 0F to a 50% F. And then if you do 2 bullet points, you go up to D, 3 you go up to C, 4 you go up to B, and 5 you get 100% at A. So you can see here, it's actually kind of snazzy. You can see the character stays centered on the screen most of the time. But when you get close to the edge, the character moves and the screen doesn't, which I'm kind of proud of. I'm actually kind of happy with how this worked out. It actually is a nice little top-down 2D map that you can walk around on. It doesn't really flicker. Looks pretty good. This is Ncurses in action. Okay? And then I can just hit the Q key, boop, and it quits out. All right? So this is turning on Ncurses. This is turning off Ncurses. This is the other crucial function right there in Ncurses. If you ever make your own Ncurses function, the two main things you need to know are mvprintw and get character. Okay, so this code here is there a way to do it without using cin or cout? Why would we want to exit Ncurses to do it? If you want, you can probably get by without using any cins or couts. Then just stay in Ncurses mode the whole time. That's fine. More power to you. I'm just saying though that because like reading in a string is really annoying using Ncurses because you read like one letter at a time. You have to like append it to the string and stuff like that. Echoing it to the screen is kind of annoying too. So if you want to make reading in a string easier, drop out of Ncurses mode, use CN. But if you want to do everything in Ncurses, go for it. You know, at the very bottom, you want to drop out of Ncurses because it clears it. It will screw up your screen if you don't quit properly out of it. So, right. So getcha. So getcha returns a character, but it's not a character. Look at that. It does not care. Right? Because some people pronounce char care, right? It's a care. Carrier? No? Okay. It does not care. It is actually an integer that it returns. And the reason why it returns an integer instead of a character is because it needs to be able to return things like thank you. At least one person thought that was funny. It needs to be able to return things like the page down key and the page up key and F7 and up arrow and left arrow and down arrow and all that kind of stuff. So it can't just use ASCII codes because there's not enough. And if you want to, where is the Ncurses file? There it is. So if you want to know actually which keys exist, you can always locate Ncurses. It's going to probably be in user include. There we go. Vim user include Ncurses.h. And you can see it's just full of like stuff, right? And there's a lot of stuff in here. One trick that's really useful in Vim, it's not really a trick, it's a core function that everybody should know, is to type / and then you can search for a key that you're looking for, like the right arrow key, right? So if you type right, okay, we're getting copyright. Maybe let's use left instead. There we go. WA left, another left, another left, another left, another left, path left, arrow left, left, key left. There we go. Okay, and so here we go. Here's a list of all the different keys that can be returned by getcha. So if getcha returns the left arrow key, it's going to return 404, key not found. But you don't need to know about any of these numbers here. Actually, that's octal 404. You don't need to worry about any of that stuff. All you have to do is say if the character returned double equals key left, then that was an arrow key, left arrow key. If they typed in page down, page up, command key, there's a ton of things that it can return here. F0, F1, F2, F3, F4, F5, all those kinds of things. You can have your Ncurses code handle all of them. And one really cool thing it can do, and my library can do also for that matter, is it can actually handle mouse events. So you can have it, you can click on the screen. If you are making like a card game, you can make it so that you could like click and, deal cards or whatever, which is kind of cool for a terminal, right? For a terminal game to have mouse support is actually kind of fun. And my colors library supports it as well. Now, Ncurses does do more than mine. Like it supports multiple buffers and windows and swapping between them and all this kind of interesting stuff. My library is much simpler in comparison. Okay. So basically what happens is we are in an infinite loop. Every frame, it's going to read from the keyboard, hey, did you hit a key anywhere? Did you click the mouse, maybe? If the user ever types Q or capital Q, it quits. And then that jumps down to the bottom and turns off Ncurses and quits. Otherwise, it's going to do a little, was right arrow pressed? If so, move to the right and do some bounce checking. Did they hit left arrow? If so, move to the left and do bounce checking. They hit up arrow, lower the Y, because remember, 0 is the top row. Y goes down as it gets bigger. And then if you hit the down key, Y gets bigger. And again, we bounce check a little bit. And if no key is hit, if you don't hit any key at all, in Ncurses, it returns error. It's not really much of an error because 99% of the time, no key is being pressed, right? I'm not hitting the key on my keyboard right now at all. It's constantly returning error, but it's not really an error. And so if nothing was pressed, do nothing. You can actually have semicolon by itself as a command. What does it do? Nothing. The reason why I put it here was just to make it clear I'm not doing anything if they don't hit any key on the keyboard. I could delete this entire little branch here. Like all 3 lines there could be deleted, but I wanted to show you guys with my demo code, like how to handle like if nothing is pressed. Right? Okay. And then you are going to need to write code to make the player bounce off a wall. Okay. In fact, there's code even in here like this. You're going to need to write a get function. There is no get function on the map. You're going to need to write one. And, you basically pass in your x coordinate, your y coordinate, and then the get function, which doesn't exist, you have to write it, should return a character holding what is on the map at that location. So we just moved. We're going to check, did we just move on top of a wall? And if we moved on top of a wall, then we set our location to be where we were last frame. Okay. And then at the end of the frame, it just saves your current location into old location. And so this is a very clever way of doing bouncing. You just try moving onto the new square. If your new square is a lake or a wall or something like that, then you set your location to where it was last time, and you bounce, essentially. This is how you can clear a spot on the map. So you'd use the set function. The set function would take an X location, a Y location, and a new character to write into the map at that point. So if you walk over a treasure, you could pick up the treasure, and the spot becomes open in the map. You've grabbed the treasure, and you can like increment your money or whatever it is you're tracking the dollars with. And so this code here draws the map to the screen. We'll get into the map code, I guess, next. That seems like an easy segue. But that's all of main. So this is all of main. The only other thing down here is the uSleep, which is you think it's a good idea to modify the map to store objects with additional data instead of simple characters. You could. It would be a pretty major refactoring as far as changes go. But you could do it. Definitely. So you make it a 2D array of shared pointers of actors or something like that. You can probably do that. Okay, so what does uSleep do? uSleep pauses the program for a number of microseconds equal to whatever parameters passed in. So if I were to uSleep for 1,000,000 microseconds like this, then it would sleep for 1 second, right? Because I'm pretty sure a microsecond is a millionth, right? So I'm dividing this by max FPS to set a frame rate cap on the game. Because if you don't, terminal-based games run really, really quickly. And you can actually like have an absurd amount of data flowing down your pipe because it's like updating 600 times a second. And you can't draw 600 frames per second on your monitor, probably. I don't know, you might have one of those super high-speed gaming monitors or something, but at the time that I made this code, I had a 90 hertz monitor, so I capped the frame rate at 90. And so it will not update the screen more than 90 times a second. That's what our uSleep here is for. So whatever your frame rate is, you can punch that in. The main goal here is just to not have the terminal like spazzing out, sending like 500 frames of data a second when you can't even draw that much. It might cause flickering. I don't know. Who knows? Okay, so that is the map. That is the main. We're going to look at map now. So map is a class. And inside of main, you instantiate the class probably just once. Yeah. It might be a good idea to like delete the copy constructor or something like that so you can't accidentally duplicate the map. You can see here, this is important. When you have a header file, you should not put using namespace standard into a header file. That's why I am booing at myself here. Because I didn't want to type std all over the place here. Std : vector std : vector std . Nah, I didn't want to do it. But in general, it's considered bad practice to do a using namespace standard in a header file. and that might sound weird for me, right? Because I'm on team using namespace standard. So is UC Riverside for that matter, and that kind of made me the guy that makes Zybooks, right? He's on team. Let's use using namespace standard. It's less typing, right? It's only if you plan to use multiple third-party libraries. Yeah, that's the main reason why you'd want to use it. But in a header file, 90% of people don't use using. They don't like it. And so if you put using namespace standard in a header and somebody includes that header, you've now decided for them that they are going to be using namespace standard and they will get pissed at you. So for this homework assignment, it's just you to you. So it doesn't really matter. But in general, it's considered bad practice to make a header file that other people are going to use that have this in there because you are making a style decision for them. And they don't like that. It's much better to just not use it and suck it up and just be verbose. Pretend like you're a Java programmer for a day and just, type 500 times more characters than you need to. I love using Ncurses. It's easier because I'm lazy. Yeah. The less things you have on the screen, the better, in my opinion, because you can see what's important. I sense some shade towards Java. I was a professional Java programmer. I don't think it's any secret that Java is a verbose language. It just is. They like having a lot of text on the screen at once. That's just their way. I am personally, I don't like how C++ has become very verbose these days. If you look at how you do timers and things like that, it's chrono : high _ resolution _ timer : now open close parentheses to just get the current time. This is modern C++. Stood : chrono : high resolution clock : now. That's how you get the time. In C, it's time or clock. You see, just yeah. I like less typing. That's just me, though. I don't know. Okay, auto doesn't help you there. Auto does not help you with that. You can't use auto with that. You can using namespace stood and using namespace chrono, but or you can alias high resolution clock, and cut that down, but you can't use auto with it because you're calling a static method. Yeah, you have to alias it. So do using HRC equals stood : chrono : high resolution clock, like that, and alias it down, and then you can do auto equals HRC now, like that. That's how you get the time without being too verbose. Okay. So what do we got here? Well, speaking of static things, now, these things are static member variables. And these are you've probably not seen a static member variable before. What is a static member variable? What this means is that this is a member variable of the class and not of objects of the class. So if I was in main, normally, let's say I'm in main. I'm pretending I'm in main. Normally you do something like this. You map m or something like that, right? You make a variable of the map type. And if you wanted to get its size or something, you'd be cout m.size or something like that. With a static class variable, you don't need a variable at all. You can just say map : hero, like this. I might not have any variables actually of the map class, but I can still access hero from it because it's associated with the class and not with objects of the class. It's only set once. There's a single constant called hero that is associated with this class. And so you say map : hero, use what's called the scope resolution operator here. And this will print out capital H to the screen. So this is common if you have insects. You could cout, insect class : legs, and it'll print out 6 to the screen because all insects have 6 legs, or start with 6 legs, max legs of 6, right? Are spiders insects? What do you guys think? Spiders insects? Are they bugs? I don't know. Demons. So you can print out how many legs insects have, and how many legs spiders have, without ever actually making an insect or a spider. It's kind of cool. Oh. That's what's going on with the static thing here. So, no, spiders are not insects. They eat insects. All right. If you have arachnophobia, don't play Hogwarts Legacy. There are a lot of spiders in that game. Okay. So I've got a init function here. The init function can be called directly with init, or because I've got a constructor, it just calls init also. And so what we got here is, again, we're talking about the verbosity of modern C++, how many words they like. Instead of using rand or something like that, you have uniform underscore in underscore distribution, angle bracket in, close angle bracket. They just like typing a lot. I don't like it. I'm not a huge fan of this. Okay, but it is the proper way of being able to roll a die. Clear the map. Resize it to be 100 by 100. And then for every spot in the map, for every row, for every column, if we're on the edge, if we're on row 0, column 0, rows -1, columns -1, then we put a wall. So the map is going to be bounded by a wall, so you can't run out, hopefully. On the center part, size divided by 2, size divided by 2. On the center part, we put the hero. So the hero starts in the dead center of the map. And then for every other tile, we roll dice and sort of randomly generate a map. So every tile has a 5% chance of containing a monster. If it doesn't contain a monster, then it contains a 3% chance of having a treasure on it. If it doesn't contain a treasure or a monster, then it has a 10% chance of being a wall. If it doesn't have that, then it can roll water, 3% chance of water. But this is kind of clever. If the row above us, or the row below us, or the column to the left, or the column to the right is water, then there's a 40% chance of water. So this creates clusters of water. I'm actually kind of happy with how this turned out. So every time you generate the map, let's not save this. Every time you generate the map, you can see that the water kind of pools together, right? So instead of just having, when I first did this, I would just randomly scatter water tiles, like the walls. You can see this doesn't look very good for water. You know, water just doesn't make sense when you have like it scattered like that. And so what we have instead here is the map comes up with like clusters of water, which kind of looks a lot better. I'm canceled because I said GIF. You guys are still on the spider topic, huh? Okay. So this is the map generation up here, and then down below it, it will draw the map, and it's fairly clever. I'm kind of happy with how this thing works. It basically has a sliding window of like a 30 by 30 zone inside of the 100 by 100 map world. And so when you're in the middle of the map, the hero's in the center and the window is kind of around you. That's what this is doing here. It's going to, so if your display size is 30, it goes 15 to the left, 15 to the right, 15 up, 15 down, and it grabs that chunk of it. If, however, you are near the edges, then the character moves instead of the window moving. And so it just can't, I don't know. I'm just pleased with myself. I don't know what to say. So, yeah, starting at the beginning row, ending row, beginning column, ending column. So this is, like I said, a subset of the overall array. This is Ncurses. It turns on underlining and it turns on bolding. So it's going to draw the hero if we are the hero of the year. No, sorry, if the tile that we're drawing is the hero tile, then it draws an H. Otherwise, it grabs the value that we're at, that we're drawing. If it's a wall, we set the color to 5. If it's a water, we set the color to 2. If it's a hero, we set the color to 3. Yeah, which I don't think is going to happen because we handle the hero up here. And if you're wondering where those colors came from, what does color 3 mean? When you set up Ncurses, it actually creates the colors. It creates a color slot 3 is green, and color slot 2 is cayenne or cyan, depending on where you're from. And color slot 1 is white or whatever. This is foreground color. This is background color. So if you want to have a monster pop out like your boss or whatever, you can set the background to be like red or something and the foreground white, and then it will really, pop out of, I mean, not literally, but like it'll pop on the screen. And then it does a move add shit. So this is the same as the print W, except it prints a single character. So it moves to this row here. It moves to this column here. And then it prints a single character there. So it goes there, prints a character. And it turns on the color for the color the rot. Treasure is gold and walls are red or whatever. And then it turns off the color. I don't necessarily need to do that. I don't actually need to turn off the color, I don't think. I could probably just move that down to here or something, but either way, doesn't matter. Doesn't eat up too much bandwidth. Okay, so that is Ncurses. That is the map code. The final thing do you guys need to do about the two colors? Yeah, so the first is foreground color, right? Foreground color and background color. And so if I make the walls color, let's do something obnoxious here. Cayenne, cyan. Now we've got a cyan background for the walls, and oh lord, that is disgusting. That is like one of the worst color combinations I can think of. Bright red on a cyan background. Oh, heresy. All right, let's go back. It's educational. You're not going to forget it now. My neighbor is a professor at Fresno State, and he's doing a book right now on transgressive humor in the classroom. So I gotta get some good jokes from him, I think. See, it really needs to be in Comic Sans, I think, for it to really work. I guess a little bit of it is, huh? Okay, so let's talk about the doubly linked list. So Vim circular doubly linked list. This is actually a separate program. It's a complete program. It's demo code from the Bridges people on how to build a doubly linked list using the Bridges doubly linked list class. If you want to visualize your doubly linked class on Bridges, which you do if you want full points, here's how you do it. Okay. And you might be like, what's this student info thing? Like, what's the deal with that? Well, there's actually a file here called student info. And you're like, why is there student info in our RPG class? And the reason for it is it's demo code. Okay. One of the primary skills in computer science is being able to look at demo code and be like, okay, I understand how that works now, and adapt it to your needs. Like when I started working with the Bridges people, I didn't know how Bridges worked. So I'm like, you guys are going to need to send me some examples of the thing working. And once I've looked at a couple of your programs, I'll start piecing together like how everything works. Because if you look at the documentation, it'll like everything's kind of piecemeal. Like it'll say like this function does this, but it's like I need to see like a working program like overall. And so this demo code here Has its own main right here. Right? And you can see that it leads off with creating a new bridges object. And at the bottom, at the bottom of main, it has the whole like set data structure and visualize thing that renders it. And I would see these bookends, right? The beginning creates the bridges object. At the end, it visualizes. And I see this in 2 or 3 different bridges code. I'm like, okay, well, that's the pattern. That's what we have to do. And inside of the thing here, you're going to type in the project number, your user ID, and your API key for it to work. And then, okay, so that's how you set the title on a bridges project. Cool. And then here we've got this weird circular DL element, keeping it on the down low. And it's creating a linked list of student infos, but it's not making a linked list. It is making an array. Wait, what? What's going on here? Well, they just wanted the ability to just like hard code the data in the linked list. And so it starts off like you can just imagine that all this data is coming from like a file, right, or somewhere. And so what it's doing, it's reading from a file, all right, into a array like this. It's an array of pointers to circular DL elements. Here's their name, here's their major, here's their email address, things like that. And then once the data is read from the file, which is what that array there is really simulating. It's simulating being a file, really. Then we do our linked list code. And this is fully functional, operational linked list code. You actually don't need to know anything about linked lists to do linked lists. It's done for you. You just need to make it work with your hero or monster class. Okay. So you made an actors.h file and have been using student info to construct a class in actors.h. Yeah, you can do that. Although it's a bit weird having students in a RPG game. I don't know. Maybe it's not. Some sort of Mary Sue or something. I don't know. Okay, so we start off with head equal to null. All right, so here's the actual linked list code. And then it's saying for every element in the student's array, it's going to prepend them. It's a prepend operation. It's going to add them to the beginning of the list. And technically, I think they actually don't even need this. Unless insert front is weird. If you do it right, you can just have this handle null properly. Whatever. So it's going to add... yeah, you could have it handle the null, but whatever. So if the list is empty, right, when I is 0, it just sets head to be the pointer we had before. Remember, all these guys are nude, right, up here. Called new a bunch of times, and we've just saved all those pointers into an array. So we start off by setting head to point to the first node, and then 4 times after that, we are going to prepend the next pointer before it. And then it'll set visual attributes. You can actually delete all of this if you want. Personally, I would like color code, like heroes to be team red and monsters to be team blue or something like that. You know, what it's doing, it's actually grabbing the students' favorite colors and setting the thickness based on their credit hours and things like that. It's way too involved for this homework assignment. I would just delete all that and just maybe color code it based on like the status as a hero or a monster or something. And then, I think this code would crash if current was null. So if we didn't have any elements at all, this would actually segfault, I think. Yeah. Okay. And then at the bottom, it calls set the data structure to head. Head is the beginning of the doubly linked list, and you call visualize. Visualize only works, though, with the bridges doubly linked list class. Only with this class here does visualize work. If you make your own, it will not visualize. The whole point of bridges is that they've got these data structures that have the ability to draw themselves on the screen, basically. It's pretty cool. This was literally designed for this class. So CSI 41 was the impetus for, I mean, not at Clovis Community College, but data structures in general. That's why bridges exist. So you can like visualize your data structures and see them. And then you've got all this code here for insert front that is just going to prepend a node. All the pointer stuff is all done for you. It works fine. You don't have to worry about it. Cool. So for your code, you need to build a doubly linked list when you go into combat, like if you have a hero or two fighting some monsters, put them into a linked list together and sort them by speed. And it's easier to sort them by speed if you sort them while they're still in a vector. If they're still in a vector, you can sort them by speed easily. Sorting a linked list sucks. So I would sort it first and then just copy all the nodes over, just like here, you know. Like if you have them in order already, it's really easy to just add them, you know, to the linked list. Right? So that's my advice. There is a sort function for the list class in C++, the standard library list. But in general, if you're holding stuff in a vector, I just put them all into a vector, sort by speed, and then build the linked list out of it, and then visualize it. Okay. So the idea that I had here, so Divinity Original Sin 2, one of my favorite RPGs of all time. I've never beaten it, just like Skyrim. I've played hundreds of hours of Skyrim, never beaten Skyrim. I've played like 5 games of the Divinity Original Sin, and have never beaten it. I've gone to the Act 3 like a number of times, but never actually beat it. So what I was kind of imagining was this. So this is a turn counter, right? It's like your initiative counter. And so it's currently the Red Prince's turn. And then after he goes, this monster's going to go, then that monster's going to go, and then this guy's going to go, then this guy's going to go, then this guy's going to go. And then it's going to wrap around back to the Red Prince again, right? It's a circular list. So each time you go to the right, go to the right, go to the right, go to the right, eventually it wraps back around and it's the Red Prince's turn again. And when you kill somebody, you just delete them out of the list. And you'll see the portrait vanish, and you just keep going. This is how turn counters work in video games. Yeah? How D&D games work. Yeah, you have an initiative, right? And occasionally you play games with it, like you delay or you ready an action or something. But in general, like you just have player order, and it just, all right, initiative 15, initiative 14, initiative 13, and you just keep, once everyone's done, you wrap around to the top again and keep going. So the Larian, the people who made Divinity Original Sin 2, are making Baldur's Gate 3, which I'm very excited for. It's coming out this summer, I think. It's been in early access for a couple of years now, I think, but I'm kind of excited. BG3, here we go. I had the opportunity to work on Baldur's Gate 2, so that was like one of the great like life forks in my road. Fergus Urquhart, who was the kind of head of Black Isle Studio, wanted me to come up to Orange County to talk about working for him. And I decided to stay in school and get my degree instead. I was in grad school at the time and I wanted to get my master's, you know. Or was I still an undergraduate? 90. When was BG2? Yeah, like that would have been wild though. Like Baldur's Gate 2 is like one of the best RPGs of all time. 2000, yeah. So 99, yeah. I would have been working on Baldur's Gate 2. Hey, who knows if he would have hired me? But he said, you know, computer science students from UCSD are really good. Come on up. Let's talk about, you know, hiring you. And I was like, can I finish my degree first? Like, no, you have to quit. So I didn't do it. And, you know, I mean, now I'm a professor, and I guess that worked out pretty well and stuff. But it would have been pretty amazing to have worked on Baldur's Gate 2. It's one of my favorite RPGs of all time. Right up there with another Obsidian game, Fallout New Vegas. So, all right, so that is basically everything I have for you for today. If you have any questions, I'm going to be hanging out. So please hop onto Discord chat rooms, or however, Octopath Traveler 2 came out today. So I'm kind of excited for that too. I'm still playing through Hogwarts Legacy though, so no SFML questions. Oh, are you doing it for your homework? Okay. Yeah, I don't know. I haven't very much used SFML, so I use SDL more than SFML, but I can try to help you if you want, I guess. Okay, so I'm going to stop the recording now, and I will just be taking questions and helping you guys do your RPGs. It's due on Monday, so pay very close attention to the README file, and if you're not going to be able to complete the whole thing, try and pick off as many of the bullet points as you can. Okay, and just get something that I can grade. so that you can get as high a score as possible, even if you're not going to 100% it. Okay? So if you find out you troll people in VR chat. Okay, so yeah, let me know how I can help. I'll be here. All right, peace, guys.